Hi guys, I'm here on Bubaki and today I'm going to show you how to run some of the examples that have been built outside of NVidia NSight within a new NVidia NSight project. So I'm here on Turing actually at the moment. I've got my terminal up. So the first thing I'm going to do is start up the NSight development environment. So we do that. I drop this little ampersand on the end of the NSight command so that I get the terminal back. But if I go and launch that, I've already connected up to Bubaki. I'm going to create a new demo workspace. So I'm going to create one called Conway's demo, just so I've created a completely clean workspace like you will have. So if we hit OK after we've given that a name, I just save these in my home directory. To keep things simple, you can probably drop them into a documents folder if you've got one there as well, so you shouldn't have any problems with that. So if we go now and hit OK, it will launch NSight, and you can see I've got my NSight window up. I've got a fresh workspace. There's no projects or anything in there, so there's nothing to run. And so the first thing we need to do is create a fresh project, and to do that we go to the file menu. If we go to the new drop down, if we go to CUDA C/C++ project, that will bring up a project dialog, a new project dialog browser. And so we are going to call our project Conway's Game of Life Demo. And so from this list, the easiest one to select is CUDA Runtime Project, and that will create a template for your project. There'll be some code in that template that you'll need to get rid of, to blow away, but it sets up all the build environments, all of the build tools in the background properly, and just leave the default as CUDA 10.2. So you'll have all of the build stuff set up. You'll have the correct tool chain for CUDA 10.2. If we go to the next one, you can put your author name in there if you want to. There's no need to though. All of this stuff should be fine by default because it detects the compute capability of the card that we've got installed. So we're on Bubaki, so we've got the Tesla V100 on there, so it detects that automatically. If we just hit finish, it will create our project. So here we have our new project. So we have the Project Explorer over here on the left hand side, and if you expand that out, you've got some items in here. It has all of the things that are included in your code, so all the libraries that you've included through your include statements. So in this scenario, this has got demo code in it here. It's just it's a template project. It does some GPU summing, I believe, on the GPU, and compares it to a CPU result. So you can see that it's got all of the includes that are used for that. But if we expand this source section, this source directory, you can see that you've got your code file, your .cu file sitting here, and it has all of the functions, variables, libraries listed in there. That's just part of what the IDE provides there. And so if we work with this file straight off the bat, you can run the code that's in there. So the template code that's in there has a CUDA kernel that does some addition, does some bits and pieces in there, and checks against a result from the CPU. So it just starts up a bunch of kernels to do some GPU summing. So if we go and run that, if you hit that run button up here, it will first of all ask you to run it as a local application because we're on the machine that has the GPU, and it runs through, builds that, and it will execute it. And if you look down the bottom here, you've got a console where your output will appear. So you can see that we know that something's working correctly here because that template code has executed correctly. So I'm going to get rid of that template code because we don't want that in there, and I'm going to go back to my file explorer. I've got my Conway's Game of Life example here. I've just opened that up in the text editor. So this is an example from lecture 19 here. It's just a simple version. So I'm going to grab all of that code. I'm going to take it and I'm going to drop it into my Conway's Game of Life file. And you have to save that one. So Control S will save that file. So you can see straight away there's not too many red lines, or there's a few spelling mistakes or things it's detecting as spelling mistakes in there. but it all looks pretty good. There's no syntax errors. It's correctly detecting the kernel launch. So if we go through, we can build our project. If we go to build all, it'll run through the build of our project, and you can see that it's used CUDA. We used CUDA 10.2. Yeah, it's correctly compiled. So this is the same compiler that I was using to compile on the command line. It's very similar to the command that I was using. It's got the -G flag down there to compile as well. So really the IDE is doing exactly the same thing that that I was doing on the command line. It's got the linker in here as well, so it grabs the libraries correctly. So that's now ready to run. So if we go and hit the run button up here, you can see that it didn't need to rebuild that because I've built it, and you can see that, I'll just make this window a little bit bigger here so we can see what's going on. You can see that it's run my Conway's Game of Life example, so I've got my initial state and my final state that have been calculated there. So that all looks pretty good. That's how you run. You can run any arbitrary code in that way. You just need to create a source file in here, and then drop the code into it. If you wanted to create another file, so if we wanted to create another CUDA program, so you go and you create a new CUDA file. Let's go new source file. Let's go demo_2.cu. That should be fine. If we just go and drop that in, that will just drop a blank file in. It's actually it's dropped some test code in there already. Now, if you wanted to go and run this particular file, you would need to go and create a run configuration to run this particular file. If we try to build that, it should build. Let's go and see here. What have we done here? We've got some weird bits and pieces going on there now that I've added that in. But essentially, what have we got? We've got error in main. What have we done here? It's because we've got two main functions. Sorry, yeah, you can't have two main functions in a project. So the easiest way then is to, if you want to have multiple main functions, you have to have them in a separate project. So we might drop that file out, and to keep things simple, make sure that you have all of your individual examples in a separate project, because they'll all have main functions, because NSight doesn't like having multiple mains in there. So go and have a play around with that as you work through the examples. Remember that you don't need to use NVidia NSight in order to run the examples. You can just make them from the command line and just execute them. The makefile just uses the NVCC compiler and has the linker commands built into it, the same commands that this is executing down here when we build our code. So it's all there. To use the debugger, there's a separate video about this, but if we want to let's go and set a breakpoint. I'm going to set a breakpoint here. So you right click, toggle breakpoint. So I'm in my CUDA kernel here. I'm in my Conway kernel, and I've set a breakpoint on this line here. If I go and hit debug, it will first of all build my application, and it asks me if I want to change to the debug perspective. And the debug perspective is just a different user interface that sits within NSight, and when you change that, it brings up all of these additional debugging tools, and you can change between the debug and the C++ interface using these buttons up here on the top right hand corner. But we're in debug mode. When you start the debugger, it goes to the first line of code in the main function, so the first executable line, and it pauses there and waits for you to do something. And you can step through your code, your functions, your code line by line by using these controls up here on the toolbar. So you can step into a line, or you can step over a line. So when you step over a line, it will execute all of the underlying instructions within there and move to the next line. So for example, I just used the step over command on that printf statement, and it executed all the code within that print that underpins that printf statement to print that initial state message. And you can set additional breakpoints. So if we don't want to go through this double nested for loop command by command, so we'll just set another breakpoint after it and hit resume and move down to that breakpoint, and you can see that it's gone through that double nested loop to print out the initial state. So we didn't have to go through and step through each individual command in there. And so the next breakpoint to be hit will be the one inside our kernel. So if we go and launch that, there we go. It does a bit of jumping around because it has to go through a whole bunch of stuff and load all of the information from the graphics card, from the GPU. So here we are, the program is now paused inside our CUDA kernel. Now remember, when we're executing a CUDA kernel, we're executing it on multiple processes across multiple threads simultaneously. And so in the debug browser up here, you can access the code that's currently being executed within each individual thread. So it's broken down by block. So if we look in block 00, we can go to thread 00 and we can see all of the results in there. Or we can go to thread 2. Remember that code is executed according to the warp. So all of the code that's in warp 0 will be executing at the same time on the same processor. All of the code that's in the next warp will be on a different processor, and so on. So there's you can play around with that and see what's going on, and you can step through the GPU code and actually see the GPU results appear in the variables browser up here, and see all of the information change as you execute the lines of code. So that will allow you to debug as you go through, and you can change threads. So you can see here as we move through, if we look here, look at the row above, for example, it changes as we move to a different thread because we're executing code for a different grid point in our Conway's Game of Life example. So you can see that the different threads are executing the same code simultaneously and updating their results, and you can step through the same code in different threads simultaneously. That's why it does a lot of jumping around, because it's actually updating all of the information from dozens of threads as we step through. So that's pretty much how we go through and use the CUDA debugger. It can be a little bit clunky in places. That's just the nature. That's just Eclipse. Eclipse is the environment that the NSight environment's built on. Eclipse can be just clunky sometimes, so play around with it. Sometimes the debugger, the connection between the debugger and the graphics card can get a bit sketchy and drop information. If it looks like it's not working properly, just stop the session and restart if something does seem amiss. So it's not perfect, but it's pretty good. So that really sums up how to use the NSight environment to start up an arbitrary piece of code and run an arbitrary within a project, and edit that and debug it within the NSight environment. Now, if you have any questions, send them through. Thanks, guys.